All right, for our first lesson on sine and cosine graphs, this was chapter 11 in our old book, so we're not going to see this in our new book, so all this stuff will be done on handouts and things like that. So first lesson we're going to do is on sine graphs. So only two functions that we're going to deal with this chapter, and that's just the sine and the cosine graphs. So the first one we're going to look at in this lesson is just the sine graph itself. So here's what the basic layout of that sine graph looks like. So a few variables that we're going to identify here in a second for how those affect the graph and what they represent. But you can either see the constant, which is our vertical shift, at the end of the function or at the beginning. So you can have either look that you see here. But let me just go on down the line for what these things represent. A represents the amplitude of the graph, or at least helps you find the amplitude of the graph. If the center of the graph runs down this line right here, then the amplitude is the distance from the center of the graph to its highest point, or helps us with the center of the graph to its lowest point. And so whenever we talk about amplitude, the amplitude is always stated as a positive value because it just represents the distance from the center to either the highest or the lowest. But the A value itself can be positive or negative. So if it's positive, that just tells you that the graph begins in the upward direction. If it's negative, then the graph will begin in the downward direction. So A itself can be positive or negative. When we get to the amplitude, you'll see we always state the amplitude as a positive though. The B value helps us determine the period of the graph. So a little formula here that we always use to get the period of the graph. And the period we always just see kind of one full repetition within the function. So if this graph started right here, as it goes to its highest point, down to its lowest point, and then back to the starting point represents one full period of the graph. So on this drawing, you're actually seeing two full periods. As we started here and kind of went all the way, there's one period, and then again there's two periods. So you're seeing two full periods on the graph, but again, little formula that we use to help determine the period of the graph. And then the C value, the constant, is always representative of the vertical shift. And so our graphs can be shifted up or down. This is when we start graphing these, I actually go in the order of C, B, A to graph it. So I always go that direction. So I always start by just determining the vertical shift if there is one. If there's not, then that just means our graph is centered on the x-axis. So this is what we call the midline of the graph, is the center of the graph, the center line that runs through the graph. So this word got cut off, but there we go. So we get the midline of the graph runs right down the middle. So again, it's on the x-axis if there is no vertical shift. So let's go through a couple examples for how we would graph these. So again, as you look at example one, I always start with the C value, the vertical shift. In this case, there is no plus or minus anything, no constant separated from the function that would give us the vertical shift. So we know this one is going to be centered at 0. So the midline of this graph is going to be at 0 or on the x-axis. So again, I'm going to put an M here just to represent the midline of the graph. Then from there I jump over to the B value to determine the period of the graph. So for this one, I know the period is 360 divided by B. So that means every 180 degrees, I should see one full period of the graph. It's common with the IB process in our book and the problems that I'm going to have you do to give you some kind of domain in which to graph. So this one's giving me the domain from negative 360 to positive 360, which means I would get 4 full periods of this graph within that window. So that's what we should see. So we know the period's at 180. Lastly, I go to the A value, which in this case is 3. So that helps us with the amplitude of the graph. So we can now start graphing this now that we know all the information. So all of these will start at 0, 0 for all your sine graphs that don't have a vertical shift to them. But we always start right here on the y-axis somewhere to place our first value. So in this case, we didn't have a vertical shift, so we start at 0. So according to this, I have an amplitude of 3. So I know I'm going to go up 3 units, and I know I have one full period of 180 degrees, within every graph you will always make 5 marks to represent a period of the graph. So we already made the first one. I know the last one is going to be right here at 180. Right, so I'm looking for the 3 marks in between those. The easiest thing to do, I think, is to just take the period of the graph and break it up into 4 equal parts. So this number tells me every 45 degrees I should be making a mark. And if I do that right, I should land on the 180. So for this one, if I make a mark every 45 degrees, so just to go off the numbers that are already there, that means I'm going to have a mark. Here's 45 degrees, there's another 45 degrees. So that's going to help me determine the points in between. So every 45 degrees I make a mark. According to this, it's going to be 3 units up from our starting point. So here's our 3 way up here at the top. So I know 45 degrees, I make my first mark, and I'm going up 3 units because of this. I then go down to the midline at the next 45 degree mark. I then go down 3 units at the next 45 degree mark, and then I'm back to the midline for my last mark. So one period of the graph, if we just trace those points, would look like this. So there's one full period of the graph. Now I'm going to extend this to fit the window that was described here, but I have just completed one full period. From there, the rest is easy. I just continue on the same path that I've already been drawing here. So one thing to note, because this was positive, is why I went up 3 units at the first 45 degree mark. Had this been negative, I would have gone down 3 units at the first 45 degree mark instead. So anyway, that's the full process. From there, you just continue the trend. A sine graph always starts on the midline, then moves with the amplitude, goes back to the midline, amplitude, midline. It always follows that pattern. So, and I can keep following that extension. So I'm on the midline, so I'm going to go amplitude, midline, amplitude, midline to continue the trend. And again, I'm making a mark every 45 degrees because I did my period divided by 4 to figure out how often I make my marks. And so again, I could do that the same thing going the other direction. Again, if I just follow the trend of the graph, right, midline, amplitude, midline, amplitude, midline. And again, I could just keep going until I've completed the entire domain that they asked me to graph. So bear with my drawing here. These get uglier as I start going a little quicker. So there we go. So we looks like we got 4 full periods within that domain of negative 360 to positive 360. So as we go through these, that process is just going to carry on. I'm going to do the same thing every time. So I'm going to start with my vertical shift. This one is at +1. So that tells me that the midline of this graph is now up 1 unit. So that's always where I begin, is figure out where my graph is centered. I then go to the B value. In this case, think of this as 1/2 x. So I know my B value is 1/2, which means the period is 360 divided by 1/2, which is 720. So one full period is 720 degrees, which means that 720 right there is going to give me one full period of this graph. From there we go to the A value. I can see my A value in this case is 1 technically. That's 1 sine x over 2. So this guy will only go up or down 1 unit from the midline. And then to figure out how I'm going to start this guy, I like to take the period of the graph and break it up into 4 parts. So let's see. So that means every 180 degrees I should be making a mark. So we always start on the y-axis, and we start on the midline of the graph for the sine graph. So from here, based on this, I now know that I'm going to go up 1 unit, and I make the next mark at 180 degrees. So from here, I'm going to go up 1 unit, and I make that mark at 180 degrees. And remember, the pattern of the sine graph does midline, amplitude, midline. So the next 180, I'm now on the midline, and this would keep going, except I'm at the end of my domain, so I'm going to stop right there. So to the right of this graph, I'm only seeing half a period. Right? But if I continue the trend on to the left, remember, I'm making a mark every 180. So in this case, from the midline, I'm going to go down 1 unit and make that mark. The next 180, I go back to the midline at the next 180, and there we go. I'm only going as far as the domain asks me to go. So there's my graph. All right. Moving on to the last example. I do have a 4th example on these notes, but we don't do any horizontal shifting. So we're not going to be doing example 4. So this will be the last one. And again, if you're watching the video, if you're just doing this for practice, I would encourage you to pause right here and try one on your own from what I've already shown. But remember, I start with the C value. So in this case, I have a positive 2, which means this graph was shifted up 2 units. So the center, or the midline of the graph, is at positive 2. I next go to the B value, which in this case is 1. So for this guy, I know the period is 360 divided by 1, which is obviously 360. And the A value in this case is negative 3. So I know I'll be going down 3 units to start this graph. And how far horizontally do we travel? Well, take your period, break it up into 4 parts, and looks like every 90 degrees I should be making a mark. So remember, we always start on the y-axis because we don't do any horizontal shifting. So in this case, I start on the midline. Remember, the trend of a sine graph always does midline, amplitude, midline, amplitude. So we start on the midline, and according to this, I need to go down 3 units at the next 90 degrees. So I'm going to go down from the center. I'm going to go down 3 units at the next 90 degree mark, and there's my first point. At the next 90 degrees, I always go back to the midline. At the next 90 degrees, I now go up 3 units, and then the next 90 degrees, I'm back at the midline. And so remember, I'm using this idea right here to tell me how often I should be making my marks. And this just tells me how far vertically I travel from the midline. So according to this, here's what our graph will look like. There's 1 full period of the graph, and I'm at the end of my domain. So I'm going to stop there on the right side, and I could continue on this trend to the left to finish it off. So if I continue on the pattern that I see, I'm going to go up 3 units at the next 90 degrees, back to the midline, down 3 units, back to the midline, and the pattern continues. So for these, we only go as far as the domain asks us to go. And there we go. Quick side note, I'm going to show you how you can do all this in your calculator as well, or at least see what the graph should look like. You should know if you're doing this, right? So if I go into the calculator, make sure your calculator is in degrees, and I'm going to go to my y equals and graph this function. So it looks like this. I can tell by that domain setting that I should be going from negative 360 to positive 360. So if I go to my window, negative 360 to positive 360, and as far as the y values go, right, based on this, right, I can see, you know, any number that would allow me to go at least as high as 5 because remember we started at 0, but this graph was shifted. According to this, it was shifted up 2 units. So it shifted up 2 units, and then because of my amplitude, we went at its highest point another 3 units. So from 2, I went another 3 units up, so I should go at least as high as 5. So you can kind of toy with your own y values on this. So negative 10 to 10 is a pretty safe range to use on this. So I'm going to hit graph, and I should see the same graph that we did on our paper if we did this right. So we can check and see. That should be the same graph, and so that's an easy way of checking to make sure we did this right.